Pascal's triangle, question 2. Expand and simplify binomial power x plus x minus 3 to the power of 3, right? So that's an easy one. Let's first make our Pascal's triangle and then see how we can write the power, right? So 1, then we go like this and we get 1 and 1, and then again 1, 2 and 1. So this is our second row, right? And then the third row. So I have taken purposely very simple example just to show you how we need to do it, right? And then once you understand, you can solve any complicated problem. So in Pascal's triangle, what is happening is we start with the 0th row, so we get 1 there, and then from here we move downwards. We can move only diagonally. So when you move diagonally, left or right, there is only one option, so you get 1 and 1. From this position, you can move diagonally towards this side and that side. So if you move this side, there's one way and you get one option. But to come to this position, there are two ways. You can come from here and you can also come from there, right? So you get 2. Every term in Pascal's triangle is sum of previous 2. Do you see that? Every term is sum of previous 2. That is how it is. Now going on this right side, there's nothing here, so it is only 1 and then 1, correct? Then we come to the third row. When we come to the third row, if you move outside, then there's one way, and so we get 1 here. But if you move inside, you could come here from that route also. So there are two ways to come here, and then this place will be 2 from here and 1 from here. It becomes 3. Now to this position, you can again go 2 ways from this side and 1 way from that side. So there are 3 ways to reach this point, correct? If you are going diagonally towards the left side, there is only one way. This is your way to go, one way, right? So we get 1 here. So it's a reminder, every position here is sum of previous 2 diagonally, right? So 3 is 1 plus 2, 2 is 1 plus 1. Do you see that? This 3 is 2 plus 1, and that is how you get your Pascal's triangle. I know we need only x minus 3 to the power of 3, and next row is not required, but just for giving you I will leave this for you to do. If we have to have the 4th row, then you figure out what should be the terms here, right? Here it will be 1, 1 plus 3, 4, sum of previous 2. Do you see? Sum of previous 2, correct? Now in any case, when the power is 3, we need to use the terms in the third row. So this is our third row, and that is second row, right? Before that, the first row, and the initial row is called the 0th row, correct? To give you one more correlation here, 0th row, what is 2 to the power of 0? 2 to the power of 0 is 1. So we got only one element here. What is 2 to the power of 1? We got 2 terms here, 1 and 1, 2 terms, right? What is 2 to the power of 2? 4. So if we got 3 terms, but when we add them up, we get 4. 1 plus 2 plus 1, 4. And how about this? 2 to the power of 3 is 8. So when you add these terms, 1 plus 3 plus 3 plus 1, we get 8. You see, 3 plus 3 is 6, 7 and 1, 8. So what we get here is the sum of all the terms here is actually 2 to the power of something. That is also a good relation to kind of remember and check your answer, correct? So you could always check your answer using 2 to the exponent of row number, okay? So 2 to the power of n will give you sum of all the coefficients here. These are the coefficients of our power, correct? Now let's see how to expand it. So we have x minus 3 to the power of 3, correct? So we will use the third row, which is this one for you, correct? Now how does it work? If a and b are two numbers here, then sum of their powers will always be equal to the total sum, which is 3 in this case, right? So the combination is a and b total will be 3, the degree will be 3 always. We start with the first term, highest degree, and then we have combination like 3, 0, 2, 1, 1, 2, like that, right? And these becomes our coefficients. So for the first term, coefficient is 1. It's not a good practice to write 1, so we'll avoid it and write x to the power of 3, x cubed. Now, second term will be plus, coefficient is 3, so we'll write 3 here, and term is x. Degree of x will decrease by 1, so we get 2 here, and then we get the second term, which is minus 3 for us, to the power of 1. So 1 plus 2 becomes 3, correct? Next term will be, coefficient is 3 for us. Here we write x. Degree of x decreases further by 1, so it becomes 1. But degree of minus 3, the second number here, increases. It becomes 2 instead. So 2 plus 1 is still 3, right? Plus the last term for us, coefficient is 1. No need to write 1, but the degree of this term should be 3. So we get 3 cubed here. Do you see that? Now we'll simplify it. So we have x cubed here plus 3x squared times minus 3. So that minus 3 will make this minus, right? And 3 times 3 will be negative. So it's better to write here negative 9x squared. Does it make sense? Yes. Now here we'll first see this power, because that is going to make negative or positive. When it is square, it becomes positive, so this remains positive. So let's make it plus 9, and this is x, correct? Now in this case we have minus to the power of 3, that means it is negative, so we should write negative here, correct? And 3 cubed is 27. 3 times 3 9, 9 times 3 27. So we get this term. So we have the expansion of x minus 3 whole cube, which is x cubed minus 9x squared plus 9x minus 27. So that is how, using Pascal's triangle, we can expand x minus 3 to the power of 3. Okay? So that was simple, but we have learned the concept of doing it here, and we will apply it to the next problem, which is kind of complicated. All the best.